Okay. Yes. Yeah. The problem goes this way. The problem goes this way. I want everyone to make a note of it, even though I'm sending you the whiteboard PDF format. I want everyone to make a note of it. Solve d squared y of t divided by dt squared, d by dt squared of y of t plus 9 y of t, that would be equal to x of t. Okay. So now, where x of t would be equal to cos 4t. Okay. So this is the given differential equation where we have to find out the natural response as well as the forced response. Okay. Calculate the natural response. Calculate the natural response and forced response of a system. Calculate the natural response and forced response of the system. Okay. Now, so first thing what you are going to do is to find out the natural response. So you are going to calculate the natural response here. Okay, that is yn of t. Okay, so first you are going to calculate the natural response of the system. So that is quite easy for you once you have the input in terms of the sine function or the cosine function which is there. So how we are going to calculate the natural response? Okay, d squared y by dt squared plus 9y of t. Okay, natural response is to be found with the input being equal to 0. So there is no effect on the input. So here the forced response comes into picture while you are calculating the input, that is taking the input into consideration. So I can equate it to 0. Next, what I'll be doing? So I'll be having a squared plus 9, that would be equal to 0. So is S1 equals plus J3, right? Is it clear? So plus J3 and minus, that is the roots of the equation. So plus or minus J3. So where you can have is 1 comma, that is one of the roots. Okay. So that would be plus J3 here, plus J3, and the second root, that would be minus J3. So it is either ways you will be having plus or minus J3, that is there. So that is in terms of the complex roots. Okay, so I have the complex roots here, the roots of the characteristic equation. So this is the characteristic equation, that is s squared plus 9, that is equal to 0. So now you are having the complex roots, that is plus or minus J3. Okay, so now I have the imaginary roots that are being present there. So how we are going to calculate the natural response? So if the roots are imaginary, look at the table which I sent you, imaginary roots. Can anyone tell me how we are going to calculate the natural response, yn of t, if the roots are imaginary? Yes, anyone can unmute and they can let me know how we are going to calculate the natural response if the roots are imaginary and complex conjugate. How we are going to calculate? So now if you are having,
into k1 cos omega t plus k2 sin omega t.
k1 cos omega t, correct. Now you plus k2 sin omega t. E power at is not there, so the value of a there was certainly 0. So that's the reason why I have been writing here as e power 0 into t. A value was 0 there, right? So I'm directly writing it as 0. This is 1. And what is the value of omega? What's the value of omega? Yes, is Purnima there in the meeting?
3, sir.
Yes, k1 cos 3t plus k2 sin 3t. This is where you go wrong. Like you just write it from the input. Okay, you write it as cos 4t there. So this is the input. You just take this one and you just write it here. So which is entirely wrong. Okay, entirely wrong. So that is where you have to find out the roots of the characteristic equation first, and there you are going to have the function there as a plus j omega, right? So that omega, what is there here? So this has to be written in the natural response equation, that is yn of t. Okay, that is where you are going to find out yn of t as k1 cos 3t plus k2 sin 3t. Okay, so now the natural response is here. Now next one, what you are going to do, you are going to find out the forced response. Okay, you are going to find out the forced response. Okay, so the forced response of the system considering the input. Okay, so I have the input as x of t is equal to cos 4t. Unless and until if you don't practice, it would be really a problem there. So now if I have the input here as cos 4t, okay, look at the structure of the forced response. How would be the structure of the forced response? Structure of the forced response. Yes, can anyone just unmute themselves and they can let me know how to write the structure of the forced response? Yes, anyone? They can unmute themselves. This shows that certain things are not being done properly, like you are not practicing properly. See to it that you are practicing day by day. Okay, so to have a better understanding of certain problems. Yes, can anyone tell me what would be the structure of the forced response, YF of t?
C1 cos 4t plus C2 sin 4t.
Okay, fine. So I have YF of t as YF of t C1 cos 4t plus C2 sin 4t. Okay, so this is one thing that is having the forced response of the system structure. Right now, using the same equation, that is d squared by yf2 dash of t plus 9 yf of t, that would be equal to cos 4t. Now what you need to do, you need to differentiate the above structure of the forced response twice. Okay, so I'll differentiate it once. I'll be having yf dash of t, so cos 4t minus c1 into 4 sin 4t plus 4c2 cos 4t. Okay, so I have minus 4c1 sin 4t plus 4c2 cos 4t. Okay, this is yf dash. Next, yf2 dash. So I am differentiating it again. Okay, now I have minus 4c1 into 4. I am doing it slowly. Sin, that would be cos 4t. Okay, plus 4c2. Cos 4t is there, so that is minus 4. Okay, into, that is sin 4t. Okay, so that is one thing that is you need to change. Minus 16c1 cos 4t minus 16c2 sin 4t. So that is what you get there as yf2 dash of t. So that would be equal to minus 16c1 cos 4t minus 16c2 sin 4t. That is there in the equation yf2 dash of t. Okay, hope everyone is getting what I'm writing here. So these equation needs to be substituted in the equation where I'll be replacing y2 dash of t as yf dash, that is double dash of t. Okay, so now I can replace it minus 16c1. Okay, minus 16c1. Next you are going to have minus 16c1 cos 4t minus 16c2 sin 4t. Okay, so these are the things that you have for yf2 dash. Okay, plus you are having 9 yf of t, 9 into c1 cos 4t plus c2 sin 4t. Okay, so that would be equal to cos 4t. Okay, so now I have minus 16c1 cos 4t minus 16c2 sin 4t plus 9c1 cos 4t plus 9c2 sine 40. That would be equal to cos 40, okay, plus 0 into sine 40. I can write it. And just make a modification here. So 0 into sine 40, because when I'm equating the coefficients of both cos 40 and sine 40, I can equate the second equation that is there to 0. Okay, now regrouping the terms, 16c1 cos 40 plus 9c1 cos 40, okay, plus 9c2 sin 40, okay, minus 16c2 sin 40, okay. So that is equal to the same equation. I can retain it here, okay. So I have minus 16c1, which is there, and 9c1, which is there, okay. So what is the end result? Yes,
7
Minus 7.
yes, exactly. Minus 7. Don't miss the sign here. That is minus 7c1 cos 40. Okay. So this here would be again minus 7c2 sin 40. Okay. So that needs to be equated to cos 40 plus 0 into sin 40. Okay. Now I can just equate the terms here. Minus 7c1 equals 1. Next, minus 7c2 or 7c2, that would be equal to 0. Okay, so c2 value would be equal to 0 here. Okay, now c1 value would be minus 1 by 7. Is that clear to you? Now I have the values of c1 and c2 being found there. So where you are going to replace it? You are going to replace it in the forced response structure, right? So now I have the value of c1. C1 is minus 1 by 7 and C2 is 0. Okay, C1 is minus 1 by 7 and C2 is said to be 0 there. Now the forced response structure would be C1 cos 40 plus C2 sin 40. Okay, so this entire term gets vanished. Okay, that's 0 there. Minus 1 by 7 into cos 40. That is the forced response structure with the constant being included. Okay, so now I have the forced response of a system. Okay, so how we are going to calculate the total response given the natural response and forced response? Yn of t plus yf of t. Now I have this forced response being given here, so I need to know what is the natural response. Let me go back there. So what's the natural response of a system? That is k1 cos 3t plus k2 sin 3t. Okay, so I have the natural response as k1 cos 3t plus k2 sin 3t minus 1 by 7 cos 40. Okay, so this is the total response of the system. Okay, this is the total response of the system. Why total refers to, that is the total response of the system considering both the natural response as well as the forced response of the system. Total response of the system. Hope it is clear to you. I'm going, I can generally go for certain approach. Okay, now how many constants are there here? How many constants are there in the total solution, total response of the system? How many constants were there? K1 and K2, two constants are there. Okay, how many constants? Can anyone tell me? Two constants are there. Yes, K1 cos 3t plus K2 sin 3t. I'm writing it again. Minus, what do you have here? Minus 1 by 7. Minus 1 by 7 cos 40. Yes. Now, how many initial conditions do you need?
2.
Yes, exactly. Yes. So you need two initial conditions, isn't it? Now, I don't know what is the initial conditions that is not specified in the problem clearly, isn't it? Now, what I can do is I can take 0 as an initial condition. Okay. So I'll be taking y of 0, that would be equal to 0. Then y dash of 0, that will also be equal to 0. I can take it. Okay. So assuming, you can take it as assuming the initial conditions, assuming the initial conditions, you can take y of 0. Yeah, initial, sorry, initial conditions. Okay, initial conditions, you can take the first initial condition as y of 0 equals 0. Next, y dash of 0, that would be equal to 0. So keeping those two constant, I mean initial conditions in mind to 0, I can find out the constants, that is k1 and k2, that is unknown constants, right? So now how do I proceed? Yes, I know the initial conditions. Where do I need to put?
Y total equation.
Yes, exactly. So what I'll be doing, I'll be differentiating this equation once more. Okay, to like go for the second one. So let me differentiate it once. K1 cos 3 into, with a negative sign, sine 3t, plus sine 3t, 3k2 cos 3t. Okay, minus 1 by 7 cos, that is there, plus 4. Is it clear? Okay. So this is the differentiated one of y total. Okay. This is the equation of y total. Okay. So the first equation was for a total response. The differentiated total response is written down. Now, what I do, I cos 0, okay, plus k2 sine 0 minus 1 by 7 cos 0. Okay, this is equal to 0 here. Cos 0 is 1.
Equal to 1 plus 1.
Plus 0 minus 1 by 7. Right? The value of k1 is found to be 1 by 7. Okay, the value of k1 is found to be 1 by 7. Now, the value of k2, y dash of 0.
0.
Yeah, 0, that is equal to, exactly. So the value of k2 is certainly found to be 0. Okay, so you have cos 0. Okay, so this one, which is 3k2, that would be equal to 0 there, right? So 3k2, if it is equal to 0, I'm just skipping a step here. So these two terms get cancelled. I mean, that's 0 there. So you are left out with 3k2 into 1. 3k2, it will be equal to 0. That is, the value of k2 would be equal to 0 there. So I know the two equations of k1 and k2, which is equal to 1 by 7, k1 value, and k2 value is set to be 0. Now, I want to write the total equation. Y total, that would be 1 by 7 cos 3t, each and every term, that is 0 into sine 3t, I can write it as 0, plus 1 by 7 minus cos 4t. Okay, so you are left out with only two terms here. Okay, so minus 1 by 7. Let me write down here clearly. Minus 1 by 7 cos 40. Okay, so that is y total. Yes, so these are the constants that I got to know, that as k1 as 1 by 7 and k2 as 0. Okay, so the next two problems, I will give it to you. Okay, so the first problem, I'll just write down here, dt squared plus 5 d by dt of y of t plus 6 y of t, that would be equal to 2 times x of t plus d by dt of x of t. Okay, where the input x of t will be equal to 2 times e power minus t into u of t. This is the first problem. So this will be solved by Lekana. Is Lekana there in the meeting? She has to solve it, and she has to let me know the answer by today. Okay. So the second problem would go like this. So you have d squared y of t divided by dt squared. Yeah, dt squared plus 3 d by dt of y of t plus 2 y of t, that would be equal to x of t plus d by dt of x of t. Okay, with input with input with input x of t equals 5 into u of t. So this one Sharan will do it, Sharan GM. Okay, so both the problems are being given there, right? So with this two problems, okay, so let me move on to the next one, okay, where you are going to find out the solution of linear differential equations by finding out the zero input response and zero state response. Okay, so this is also quite similar to what we had done with a small change. Okay, so you have to observe the change here, and then you have to let me know. I'll be asking you the question after I solve a numerical problem. So what was the difference what we had done previously with the y total and this one, that is zero input response and zero state response, right? I'll be clearly defining what is zero input response and zero state response. Okay, so here the concept of initial conditions will come into picture again, and you have to tell me what was the major difference that you find out after solving a given problem. Okay, so solution of linear differential equations by computing the zero input response zero input response that is ZIR, and zero state response okay, that is ZSR. Okay, very important concept here. So in case of your like competitive exams, okay, GATE, whatever it is that you take, in case if they ask any question which is related to a differential equation, finding out its zero input response and zero state response. Okay, so this is one of the important thing that comes into picture here, right? So now let me proceed. As I already told you, y of t, which is a continuous time output. Okay, so in any LTI systems that is there, you are going to find out the output of the system. What we did earlier was yn of t and yf of t. So what we would have done is, first we would find out the roots of the equation, that is the characteristic equation, and then we would have proceeded with the nature of the characteristic equation that is there. Okay, that is how we are going to find out. Based on the characteristic equation roots, we are going to find out what was the natural response equation would look like. Next, I had the forced response of the system. Okay, so if I have the forced response of the system, that is entirely dependent on the type of the input that was there. So that was the condition what we had followed here. Now, in order to evaluate the system, that is the response of the system in case of an LTI system, the zero input response is again equal to the natural response here. So this is nothing but zero input response, assuming the initial conditions. Okay, so assuming the initial conditions here, right? So that was for zero input response. Now zero state response, ZSR. Okay, so ZSR, that is zero state response. Again, you are going to assume it for zero input. Okay, assume it for zero input. Okay, so that is one thing that is there here. So zero state response, that is there, and zero input response, again it is equal to the natural response of a system, where we will be assuming the initial conditions of the system to be equal to zero there, right? So the total response of the system would be equal to the total response of the system, that would be equal to zero input response plus zero state response. So that is there here. So zero input response plus zero state response, that would be the total response of the system. Okay, so now how would you generally go with the procedure here? So the procedure for calculating ZIR, zero input response, and ZSR. Okay, so that is there To
Excuse me, sir.
calculate, yeah, go ahead.
Sir, can you explain the difference between both the states, sir? In that is zero input and zero state response.
Yes. Yeah. So see here. So yn of t. How are you calculating yn of t? Prashant, can you just tell me how are you calculating yn of t?
Sir, assuming the initial conditions, sir.
No, 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 no. See, yn of t, how would you have calculated is depending on the characteristic equation. For example, if it was d squared y by dt squared plus 3 dy by dt, okay, plus y of t, how you would have written the characteristic equation? S squared plus 3s plus 1, right? Are you clear?
Yes, sir. Yes, sir.
So how would you calculate the roots of the equation? Equating it to 0, you would have got some roots of the characteristic equation. Depending on the roots of the characteristic equation, I would have found out the natural response of the system. Okay, there we didn't consider the input. Hope it is clear to you. Now we equated the input to be equal to 0 without the absence, like absence of the input. Okay, so we were calculating the natural response of the system. Fine. Now, in case of zero input response, it is equal to the natural response of the system. But in case of the natural response of the system, we didn't assume the initial conditions. Okay. So here in the problem where you will be calculating the zero input response, you have to consider the initial conditions which is there in the given differential equation. Then you are going to consider the zero input responses. That's how you are going to find out the zero input response. So that's the major difference between the natural response of the system and zero input response of the system. So ZIR will consider the initial conditions of the given differential equation. So yn of t will not consider the differential, like the initial conditions which is being specified here. So next, the forced response of a system, if you want to calculate it, so you're going to calculate it depending on the input, right? So with the input being known to you, the structure of the forced response, you are going to write it depending on the table. After finding out the equation, that is yf2 dash of t plus 3 times yf dash of t and so on, what you are going to do, then you are going to calculate k1 and k2, that is the number of constants that are being given there. So in order to calculate the zero state response, you have to assume it with zero input there, right? And also the initial conditions that are being given, right? So assuming it for the initial conditions in the first one was the zero input response, and the second one was for zero input where you are going to have the zero state response there. So in ZIR, you are assume the initial conditions which is there in the problem. Next, in case of ZSR, you are going to do it for the zero input, and you are going to calculate both ZIR and ZSR, and you have to sum it up, and then you are going to get the total response. Okay, so I'll tell you the procedure how it looks like. Okay, so you have an like differential equation, linear differential equation that is there. You are going to have it as a naught yn of t. Okay, this is the order of the differential equation what I've written there in the superscript. Okay, so plus a1 yn minus 1 of t and so on. If you are going to write it, plus you are going to have an y of t, that is there. Okay, so that would be given with an input called as x of t. Okay, now the second equation, second procedure, what you are going to do is you are going to calculate the zero input response. How you are going to calculate the zero input response? Zi of t, that is the zero input response of a system, is found from yn of t. Yn of t with prescribed initial conditions. I repeat, this is the important point here, with prescribed initial conditions. With prescribed initial conditions. Okay, next, you are going to find out ZSR, Zs of t. Response, I'm writing it as y, so that's the reason why I didn't write ZIR of t or something like that. Okay, Zs of t. Okay, how you are going to find yz of t? You are going to find it out from y of t but with zero initial conditions. Okay, zero initial conditions. There you are going to have the response YF, you are going to calculate it. Okay, then with Y of t being given, you are going to calculate it with the zero initial condition. So Y of t will be the total response of the system with, yeah, let me write it here. Y of t will be Yn of t plus Yf of t. Okay, now with zero initial conditions, you are going to calculate the Yz des of t. Okay, so Y of t, from Y of t, you are going to calculate Yz des of t. So Y of t will have the forced response of the system that is being present there, right? So with zero initial conditions, if you apply to the output of the system, so you're going to get the ZSR. Okay, so then Y dash, okay, I'll write it as the output Y of t, that would be equal to ZIR plus ZSR. Okay, so that is the output, final total output response of the system, that is ZIR plus ZSR. So first thing, you are going to write down the differential equation that is given there. You will be specified with initial condition that is given. I'm just writing it here. It can be any value. Okay, so Y of 0, that would be equal to 2, something like that. So with the initial condition, it will be specified. That is the first step. Next, second step, to find out the zero input response. So you are going to calculate the natural response of the system with the prescribed initial conditions. Okay, for example, you will get it as k1 e power minus 2t plus k2 e power minus 3t. Okay, so this is there here. So you are going to have Yn of t like this, right? So next, Yn of 0, you will have some equation like 2. Okay, so with t is equal to 0, k1 plus k2, that would be there. So next, you will be having y dash of 0, that will also be having some value there as 3, right? So again, you are going to differentiate the natural response, and then you are going to get somewhat equation as 3, that would be equal to 2k1 plus 3k2, something like that. Okay, so there you are going to find out k1 and k2. So yzi of t would be equal to some value k1, you will get it as 1 by 3 e power minus 2t plus 1 by 2, some value I'm giving here. This is not the exact one. So you will get the zero input response as this one, right? I'm giving you with an example. Okay, so zero input response is to be found out like this. Next, zero state response. Now, after calculating the input, like depending on the input, you are going to find out the structure of the forced response. Next, you are going to find out the natural response plus forced response of the system that is there. Next, you are going to have the zero initial conditions. So whatever the conditions that was there as 0 for finding out the zero state response, zero initial conditions. I repeat, zero initial conditions. So you are going to give it as 0, the output of the system, to find out the constant that is there in YF of t. Okay, so then you are going to calculate ZSR. So after finding out ZSR and ZIR, you are going to have the summation of it. That would be the total response of a system, that is the solution, considering the zero input response and zero state response. Okay, so let us solve a problem in the next class, or else I'll send you the solution to the given problem. Okay, so meanwhile, what I want you to do here is just make a note of the thing, that is the procedure that is there. So try to solve